Welcome to the 1970s. We are live at a local recording studio in London. A popular band, who will remain nameless, is here to record their upcoming album entitled A Lac at the Opera. In this sketch, we'll talk about the Lac Operon. The Lac Operon is a set of genes located adjacent to each other and expressed together that allow E. coli to metabolize lactose. Let's draw the soundboard to represent our Lac Operon. Note that the color theme on the back of the studio matches the colors of our soundboard. The Lac Operon contains a catabolite activator protein, or CAP, binding site, promoter, operator, LAC-Z, LAC-Y, and LAC-A genes. When glucose is absent and lactose is present, LAC-Z, LAC-Y, and LAC-A genes are expressed, and E. coli can metabolize lactose. We'll use music to quantify Lac Operon gene expression. The Lac Operon is also associated with CAP protein, repressor, and inducer. The LAC-I gene is found outside the Lac Operon and encodes for the repressor protein. This push-to-talk button represents the CAP binding site. When glucose levels are low, CAP protein binds to the CAP binding site to activate transcription. CAP is represented by this band manager. He's wearing a captain's hat and calls himself Cap. He's also wearing a green shirt because CAP is a protein, and for the purpose of this sketch, we'll use the color green to represent any proteins. The band manager encourages the band members to make music by pressing the push-to-talk button. Inside the recording studio, you'll see a microphone representing the promoter site. You'll also see the lead singer, Freddie R. Polymerase. Just in case you didn't know, the R stands for RNA. RNA polymerase binds to the promoter site to initiate transcription, and of course, Freddie uses the microphone to sing. The Lac Operon has an operator region next to the promoter site. We've used a recording operator to represent the operator site. The repressor protein normally binds to the operator site to prevent transcription. You'll see a record label president, or record pres, repress the recording operator. He clearly doesn't want the band to record their album. Who knows why? Yep, he's our repressor protein. All right, let's welcome the other band members, Roger Weiler, John Z. Kahn, and Brian A., who represent LAC-Y, LAC-Z, and LAC-A. LAC-Y encodes for permease, which helps lactose enter the cell. LAC-Z encodes for galactosidase, which hydrolyzes lactose into galactose and glucose. LAC-A encodes for transacetylase, which transfers an acetyl group to lactose, but the function of this protein is still unknown. The Lac Operon can be turned on or off depending on the availability of glucose and lactose. Let's talk about the 4 scenarios you need to know. When lactose is not present and glucose is available, the Lac Operon is not expressed. As we discussed earlier, the record pres represses the recording operator. Or, in other words, the repressor protein binds to the operator site to prevent transcription. Instead of encouraging the band members, Cap just sits on the shag carpet munching on glucose candy. Yup, no music here, folks. Just crickets and silence. It's like entomological jazz. Okay, what happens when lactose and glucose are both available? In this scenario, the Lac Operon is only expressed at a very low level. Allolactose, an isomer of lactose, binds to the repressor protein to release it from the operator site. Allolactose acts as the inducer. Let's introduce you to Freddie R. Polymerase's friend, Allie. She pulls the record pres away from the operator. She's wearing a cow shirt to remind you of milk, which contains lactose. Also, note the Rock and Roll Hall of Fame induction poster next to her because she's an inducer. Glucose normally suppresses adenylate cyclase to make less cyclic AMP, and the CAP binding site remains empty and cannot help with transcription. While Allie is pulling the record pres away from the operator site, the band manager eats glucose candy instead of encouraging the band, and as a result, they only create little music. Okay, next scenario. When lactose is available and glucose is not present, the Lac Operon is fully expressed. If we go back to our sugar-loving band manager, note that there's no more glucose candy. We can now see an album cover showing a guy riding an old-fashioned bicycle surrounding a bunch of tents. This bicycle represents adenylate cyclase, and the tense represent cyclic AMP or camp sites. Low glucose levels stimulate adenylate cyclase to make cyclic AMP from ATP, and cyclic AMP binds to CAP to stimulate transcription of Lac Operon genes. The band manager is shown pushing the button to tell the band they're doing an amazing job and they should continue making music. Freddie is singing and the band members are playing their instruments. Final scenario. When lactose is unavailable and glucose is limited, the Lac Operon will not be expressed. The repressor protein binds to the operator site and turns off transcription because allolactose is not present. Alli is not present to stop the record pres from repressing the recording operator. Low glucose levels increase adenylate cyclase activity to generate more cyclic AMP, which activates CAP. However, LAC genes are not expressed because the repressor protein is bound to the operator site. CAP is pushing the button to tell the band to continue to make music, but the record pres is blocking the operator and Alli is not here in the scenario, and no music is made. All right, it's time to wrap up this sketch. The Lac Operon is a set of genes located adjacent to each other and expressed together that allow E. coli to metabolize lactose. The Lac Operon contains a CAP binding site, promoter, operator, LAC-Z, LAC-Y, and LAC-A genes. The Lac Operon is also associated with CAP, repressor, and inducer. RNA polymerase binds to the promoter to initiate transcription. When lactose is not available and glucose is present, the Lac Operon is not expressed. The CAP binding site remains empty and the repressor protein is bound to the operator site, so transcription doesn't happen. When lactose and glucose are both available, the Lac Operon is minimally expressed. While allolactose binds to the repressor protein to move it away from the operator site, the CAP binding site remains empty, so transcription occurs at a very low level. When lactose is available and glucose is not present, the Lac Operon is fully expressed. Low glucose levels stimulate adenylate cyclase to produce cyclic AMP, which activates the CAP protein, so it can bind to the CAP binding site and activate transcription. Allolactose binds to the repressor protein to move it away from the operator site. Finally, when there's no lactose or glucose available, the Lac Operon is not expressed. CAP protein binds to the CAP binding site, but allolactose is not present and the repressor protein remains bound to the operator site, so transcription doesn't occur.